The diagram shows a block of 12 kilograms which is connected by a light inextensible string passing over a smooth pulley to a light scale pan. So the string passes over this light pulley, it's smooth so there's no friction, it doesn't weigh anything, over to a light scale pan. So this triangular thing here is going to be the pan, it doesn't weigh anything. On the scale pan there are two blocks P and Q, each of mass of 4 kilograms and 8 kilograms respectively, with P on top of Q, and the system is in equilibrium. Draw diagrams showing the forces on the 12 kilogram block, the scale pan, P, Q, and the pulley. Draw diagrams showing the forces on the 12 kilogram block, scale pan, PQ, and the pulley. Here's the whole system just for reference. So separating each thing up, so we're going to take the 12 kilogram. So forces on the 12 kilogram block. So there's my block. So we have the weight of it acting downwards, which is going to be 12 G newtons, and then we have the tension here in the string acting upwards. Next, I'm going to take the scale pan. Okay, the scale pan doesn't weigh anything itself, however there is 12 kilograms here acting downwards, so there's going to be a weight of 12 G newtons, and then it's also attached by the same strings, which will also have a tension of T. We've got T newtons. Then we're going to take the P. So on P, we've got the weight of the block, which is going to be 4 G newtons, and then its reaction with the block underneath, which is going to be 4 G newtons as well. So the reaction of Q on P. Forces on Q. So here we got Q is 8 kilograms. So we've got a force of 8 G newtons acting downwards. We've got a reactional force of 12 G newtons, because all of this is acting on the 4 and the 8, so we're going to have a 12 G newton force acting down, and then also we're going to have a reactional force acting downwards, 4 G newtons of P on Q. For the pulley, for the forces on the pulley, we've got the pulley, we've got string here T newtons, string here T newtons, and then we've got a force here which we're going to call T1, where T1 is the tension in the rod supporting the pulley. Right, now we can answer the questions by using these diagrams. So find the tension in the string. So if we take the 12 kilogram block, then we'll just draw that again. So we've got 12 kilogram, we've got 12 G acting downwards, a T acting up. The system is in equilibrium, i.e. it's either stationary or has a constant velocity. It's more likely to be at rest or balanced. Then T minus 12G, T minus 12G is going to be equal to 0, and therefore T will be equal to 12G newtons. So the tension in the string is 12 G newtons. C, find the tension in the rod holding the pulley. So if we now consider the forces on the pulley, which is this one here. So we've got T acting down on this side, T acting down on this side, and then T1 newtons acting upwards. So the system again is in equilibrium, so therefore T1 minus T will be equal to 0. But we already calculated T to be 12 G newtons in the previous part, so we've got T1 minus 12 G newtons minus 12 G newtons is equal to 0. So we've got T1 minus 24 G is equal to 0. Therefore T1 is 24 G newtons. The tension in the rod holding the pulley is 24 G newtons. And then in the final case, the normal reaction between P and Q. So consider the 4 kilogram block of P. This is the reaction, this is the block, therefore the system again is in equilibrium, so we can say that R minus 4G is equal to 0, so R will be equal to 4G newtons, therefore the normal reaction between P and Q is 4G newtons. Okay, so this has been a video to show you how to deal with the standby, it's been a video to show you how to block a pulley system which is in equilibrium. I hope you've understood, and I thank you very much for watching.